Alright, so in this video we're going to review some very basic trigonometry. You'll need to have a very good understanding of trigonometry in this course as we go through it. So it's very important that you can recall these fundamental concepts and laws from trigonometry that you probably learned during like the first few years of high school. So what we're going to do is, instead of me just you watching me fill out all these different functions, what I want you to do is try these individual things on your own. So what I want you to try to do is I want you to try to define the law of sines and the law of cosines using this generic triangle here. So we have the three sides of the triangle are sides A, B, and C. All right, and then the three angles are of the triangle are lowercase a, lowercase b, and lowercase c. So using those variables, I want you to define the law of sines and the law of cosines. So please stop the video and try those. Try to define the law of sines and the law of cosines from what you remember. Okay. If you don't remember it, no big deal. Try it out. See what you remember. And we'll stop the video and I will then define them. Okay, and so we're back. So here are the definitions for the law of sines and the law of cosines. But again, the capital letters represent the sides of a triangle, and then the lowercase letters represent the angles of the triangle. Okay, so you can, if you know certain sides of the triangle, you should be able to determine the angles, and then if you know certain angles, you should be able to then determine the sides of the triangle. So depending on what information or what you know, you can use this law of sines and law of cosines to determine the unknown sides of your triangle. Right. So we're going to use this in the addition of vectors, which we just discussed. All right. So in this part of the video, we're going to look at the specific case of a right triangle, and I want you to using the three sides of our triangle O, A, and H, I want you to define what the sine of the angle theta would be equal to, what the cosine of the angle theta would be equal to, and the tangent of the angle theta would be equal to in terms of the sides of our triangle. So we're going to have the ratios of the sides of our triangles will define what sine of theta would be equal to, what cosine theta would be equal to, and what tangent theta would be equal to. Okay? And then I'd also like you to try to remember what is the Pythagorean theorem. So please stop the video and try to answer these on your own. Okay, so for a right triangle, we can define the sine of theta as being equal to the opposite over the hypotenuse. Okay, for the cosine of theta, what we can define it as being the adjacent side of our triangle, or the side of the triangle that's adjacent to our angle theta divided by the hypotenuse, and then the tangent of our angle theta would be equal to the length of the opposite side of our triangle divided by the adjacent side of our triangle. Alright, so you can remember this acronym or these ratios using the acronym SOHCAHTOA, where SO represents the sine, angle opposite of adjacent, CA represents the cosine or adjacent over the hypotenuse, and tangent is equal to opposite divided by adjacent. All right. So, and then the formula for the Pythagorean theorem is just equal, the hypotenuse squared is just equal to the opposite side, the length of the opposite side of the triangle squared plus the length of the adjacent side of the triangle squared. All right. And so the last bit of trigonometry that is valuable for you to understand in this course is you need to understand what the cosine of given the cosine and cosine of specific angles are for various values of the angle theta. Okay, so for example, when theta is equal to 0, we know that the cosine of theta of 0 is 1, and the sine of theta is 0. Similarly, when theta is equal to 90 degrees, we know that the cosine, or the x-coordinate on a unit circle is equal to 1, and the sine of the angle theta is equal to of 90 degrees is equal to 1 at that point. Okay, so what I want you to do is, again, see if you can fill out this unit circle on your own and test your ability to complete the unit circle and see what you know how to do it. All right, or what you remember. Okay, so this is the completed unit circle. As you'll note, the uh, both sine and cosine of theta are both positive in the top right axis, or the first quadrant of our circle. So all our trig functions are going to be positive when theta is between 0 and 90 degrees. Between 90 degrees and 180 degrees, only the sine function will be positive. Between 180 and 270 degrees, both sine and cosine are both going to be negative. But since we know that tangent of theta is also equal to the sine of theta over cosine theta, if sine of theta is negative and cosine theta is negative, we know that tangent will be positive when it's greater than 270 degrees. And then the last one would be the final quadrant between 270 and 360 degrees, and we know in that case that the cosine, or the x-coordinates in this quadrant, will be positive. All other values, both sine and tangent, will be negative. Okay, so you can remember this by the acronym all students take calc. All right, so that's it for the basic trig that you'll need in this course. Everything else should be introduced to you during the lectures. But please make sure you are aware of the law of sines, the law of cosines, right triangles, and the trigonometric functions associated with them, especially the Pythagorean theorem. And then also know for these common angles, you should know what the sine and cosines of those angles will be.